Hello everyone, D. Alfred Ostrowski. In this recording, I'm going to be exploring payable functions in the Solidity smart contract programming language. And welcome to our day 7 of the 20-day Ethereum challenge. In this recording, I'm just going to be exploring the simple mechanics of payable functions, as we will be applying it in some of the upcoming videos to a greater extent. But here I just want to present and explore some of the simple functionality of sending funds to a smart contract, checking those funds, and withdrawing them and passing them to other accounts and managing the funds appropriately, and also setting up the code and logic for testing them that are eventually going to be formulating and supporting the testing of your assertion tests that are going to be associated with more advanced smart contracts. But here we're just going to break it down and go through the simple mechanics. As usual, I'm going to be following through my instructions, and I'm going to be using exactly the same configuration as I've done in all the videos in this series. If you have not seen in the earlier videos, it would be your best interest to at least take a look at some of them, including the day 0 I do the installations, as I'm not going to be repeating and explaining through those steps, but I'm using the exact same configuration, and I've taken the liberty of running through all the steps here identified in the README install under day 7, including the setup of Node.js, associated libraries. I did not install React in this case because I'm only using the Hardhat project, so you can just start up a brand new Hardhat project under a new directory, load the smart contract, and you're good to go. So you can take note of these steps here that are identified, and we're going to move right ahead. Here I have a copy of the smart contract. I also have it under contracts in the same backed up GitHub. Now I've started my blockchain, a fresh Hardhat blockchain, and we have the 20 accounts that are available to send money or receive money from the smart contract. So that said, all I have to do is load up the Hardhat console and get started. But first, let's take a look at the contract. So I'm under the contracts directory right now, and let's just run through it. Now I have events and that are being defined and emitted here. I have a separate video on that. You can take a look at that. We're not exploring any more functionality that's explained in that video, so for brevity, I'm leaving it for that video if you want to understand it a little bit better. In this case, we're just going to run through, again, the basic functionality. So I have the contract definition, funds received and withdrawn. Again, those are two events that are going to have the associated addresses and amounts. I have a receive funds function, and it's defined as external payable. The most important definition is that of payable. Obviously, it's going to give me some hidden functionality in my smart contract of being able to receive funds in a balance that's associated with that address. Here I emit an event. It's not necessary. It's just for recording that particular event, but the function as it is empty will receive funds and allow me to update that balance. So we're going to exercise this in a second and see exactly how it works. Now it's defined as external. This is a best practice. I could define it as public. The difference between the two is that external only allows access from the outside. So if being defined as external versus public, I cannot call receive funds from any other function that I may define within Solidity. There's also additional benefits with regards to gas fees, which I'm not going to dig in right now, but perhaps in future videos I'll go into a little bit more detail as to how to save on gas fees and configure your function calls appropriately to leverage external to the highest level. But it is important to note that there are benefits both in the savings of gas, in your gas fees, as well as simple basic good practice for programming where you want to limit the access to funds, either receiving or sending, appropriately, and only allow it where it's absolutely necessary, right? So withdraw funds takes two parameters. Unlike receive funds, we have formal parameters that are being sent, the address for the recipient. This is defined as payable as well, and in a given amount, it's also defined as external for the same reason as receive funds. Here we take the recipient, and some examples, they have a formal definition of payable around that. That is, could be viewed as a good practice. It's not necessary. I can just do a simple transfer function and transfer that amount. Here I commented out the balance and I reserved it for a withdraw all function, in which case the entire balance is going to be transferred. And this is going to have a lot of utility moving forward. So just exploring a basic variation between the two. The first taking an amount, and the second, the withdraw all funds, just taking the recipient address and transferring the entire balance. Both of them will emit a related event, and that's pretty much it. We have address this. This is identifying the address that is associated directly with the smart contract, okay? And that's taking the balance that's associated with that. And that's about it. So let's get out of the editor and we can go to the basic project directory and we can start the Hardhat console, deploy, and start to leverage our smart contract. So here I started up the console, and I'm going to grab my accounts. I'm going to pass it into signers, and I did similar operations. You can look at some of the first few days of the challenge and see the same operations. I'm going to use get contract factory and read in my contract definition. Of course, it has to be in the appropriate directory. And now I'm going to do a deploy. And you can see in the background that it's being deployed on our blockchain. Just another variation here. Again, just reinforce our understanding. I could do get signers and pass it to deployer. Okay, the square brackets is give me the functional equivalent of signers at index 0. And I can take deployer address, and you see it's 9266. I can also take signers, and again, it's the beauty of the command console, okay, in my opinion, that I can do these operations and immediately get the result. And most importantly, I'm working in the JavaScript world, that I can easily take any concepts that I prove or test and easily slide that into React. So we can see 9266, that is the deployer address. It's also the signer's address, and that first address is found from the actual Ganache addresses, right, where I have the 9266, account 0, just like we've been working with before. So I can take the balance of my deployed smart contract, and that was under CD, and I could do CD, right? It's going to give me all the information related to the smart contract, and the deployer is identified here as the Hardhat Ether signer. The signer is the deployer in this case. And I also have 0AA3. It's the default address at least in Hardhat, that is defined with my smart contract as that's being deployed. So I grab a balance of that and can do CD target, give me the specific address, and we have, not surprisingly, I'm going to have 0 because that is the new smart contract and there's no money that's associated with it when I just bring it up. So now I'm going to do a receive funds, and I'm passing in a half ether, and it's a little bit better to put a weight. I can do it in the next one. That way I am always going to get the appropriate amount if I happen to check it later on. So here I did 2 receive funds, and I should, when I do a balance now, I should get 1 ETH, and it is expressed in way, so I have the conversion amount, with way obviously being a much smaller denomination than the ETH. So I can continue on with any number of receive funds. And at this point, again, I have 1. I could do it a couple more times. Like, let's just do that for the sake of being consistent with the example. And now I should be at 2 ETH. I could do the balance, and I can also do an assertion to test that. Okay, so we have an assert that is associated with just Node.js. And this is a good prerequisite of setting up our assertion testing, and do some quick testing around that we can set it up appropriately. Here we have that. I'm kind of out of order here. Now this command is, I'm going to set it up to test for 2, and I'm going to check against the balance. I didn't set a balance here, so instead of embedding it, let me just go back to the get balance, and I'm going to assign that to a variable called balance1. So I'm calling it variable balance1 is equal to the get balance of the target, and bal1 is going to be, as we see already. So that's my 2 ETH. And now I can pull in the assertion test. So I have the equal to this given amount, and then I have the balance. And in this case, I define an error message if it doesn't happen to work. If it does match the amount, I don't get any response, and I don't have the message printing out. If I set it to a different value, which is testing against that, then I get the assertion, and I get that message is going to be printed out, and I get the associated assertion error, and that's exactly what we were expecting. So now I'm going to do a withdraw funds, and I'm going to pass in a different address. So I took it from one address, I passed it to the smart contract, and now I'm going to pass it, in this case, to signers1. So the difference here is I'm not using the embedded variables. I'm using straightforward Solidity parameters. So in that case, I don't use the curly brackets. Okay, so you want to make sure that you're not confusing the from and to values that are going to be passed in, or else you'll get a mismatch error. And I posted that below, just as I typically do any type of errors I run across, or things that I think you may get an error and wonder exactly what the issue was. So here I do a withdraw funds, and I'm going to withdraw. In this case, I'm going to withdraw to the signers1, which is the second account because it's 0 indexed. And then I'm going to do a withdraw all funds. And in this case, I'm not going to put any amount. It's going to take the remaining 1.5 ethers and pass that, in this case, to signers2. So I can look at the 2 balances and see how that turns out. So I'm going to grab a balance of all 3. Okay, so I'm going to do, let's look at the balance for signer0. And we have less than 1 ether. Why? Because we took that amount and we had passed that in subsequent calls to the smart contract. And when I did the withdraw, I withdrew a half ETH and I put it into account 1, which is under signers1. And then I did the withdraw all, and I passed it to signers2. And you can see the 1.5 that's being passed in. and that is registered back into the Ether's amount in the associated account. So there you have it. Hope this helps, and we're going to be doing more advanced work with payable functions and integrating them into more advanced smart contracts moving forward. Thanks for listening. See you in the next video. Take care.